All right, so we've approximated sidereal time both with the whiteboard as well as via PowerPoint, and now it's time that we can make some general assertions and a nice little summarized detail here. They make good quiz questions or exam questions, so this is a good thing to make note of and maybe a flashcard for, that kind of thing. Okay. So of course you know what sidereal time is, but now we can apply it to this diagram that we've all figured out how to approximate with. Sidereal time is really an angle, even though it's called time, right? But it's an angle. And it's measured from, the celestial meridian clockwise to the really the hour circle of the vernal equinox, which is a definition that you kind of memorized before, but especially in this diagram, the sidereal time angle that I've been drawing in red always started at the CM, the arrow going out of the observer's head, and drawn clockwise, yes, into the arrow that is the vernal equinox straight to the left. So that's a good thing to just memorize and always apply when doing these sort of diagrams together. Secondly, a detail that we knew about, but now it becomes extra important. Earth orbits the sun by approximately, squiggle, about 1 degree per day. And therefore, at the same solar time tomorrow, that means time on your watch, or time on the clock on the wall, this sidereal time, which is star time, is really increased by 4 minutes, or about 1 degree. Remember, we keep time by the sun. The sun apparently goes around you 360 degrees every day. But the stars go how far around you? 361 degrees per day, the extra 1 degree. And who moves just like a star? The vernal equinox does. So yeah, the vernal equinox does the same thing. It is actually 1 degree further west the next day, thereby increasing the angle of the sidereal time by 4 minutes, the equivalent of 1 degree. That's becoming more and more of an important detail now. And then thirdly, if you recall that, the sidereal day, the star day, is really shorter than a solar day by 4 minutes, that makes it about 23 hours and 56 minutes long. Then we say that in short intervals of time, like just 4 hours in the future, sidereal time and solar time, if you had 2 clocks on the wall, would move at about the same speed. About. It's only after an entire day goes by that we start worrying about the fact that they're off. They differ by about 4 minutes. But in short intervals of time, like just 4 hours in the future, we talk about, the sidereal time is also going to increase by about 4 hours. In 8 hours, it increases by about 8 hours. It's only after a full day, we mean a solar day, when we say that we start talking about, the solar time, the sidereal time is bigger, but not by a full 24 hours. It's bigger by 23 hours and 56 minutes. So, it's that extra 4 minute difference that starts to accumulate after day and day and day. So if the sidereal time tonight at 8 p.m. is 8 hours, then at 10 p.m., the sidereal time is also about 10 hours. It's just about 2 hours larger. But if the sidereal time tomorrow at 8 p.m. is asked for, and it was 8 hours at 8 p.m. tonight, then what would you say? At the same solar time tomorrow, a whole day in the future, then we start working on the fact that it's 4 minutes off. So, then the sidereal time would actually be 8 hours and 4 minutes. It gets larger because the vernal equinox is now actually 1 degree past its transit, and that makes the angle measured backwards to the meridian bigger by about 4 minutes. So the next night, at the same time, the sidereal time is 8 hours and 4 minutes. The next night at the same time, the sidereal time is 8 hours and 8 minutes. The next night at the same time, the sidereal time is 8 hours and 12 minutes. Yep, it grows by about 4 minutes per solar day. And these are all details that are much easier to see and to grasp when you start, doing the diagram and you start seeing the fact that as Earth orbits and rotates, these angles are slightly, askew, are a little bit different on a daily basis. Okay. All right, now it's definitely time to work through some examples, so we'll do those here shortly.